So, our company, if I can do sessions on IP radios, so we did a little survey, and IP, one of the topics that came up. Yeah, sure. We will talk about IP radios. So, Herman, I work for you networking, so we just switched names again, but it's very will be automatically the same Aruba. Good, let's first start what customers are, where they are in their digital transformation, and IoT is one of the big drivers in that, one of the big topics in their digital transformation. So another topic that comes up, and we've had a session on safety trees already, sustainability. And what we see is that for more and more customers need to go end-to-end. So with IoT, they can get all kinds of sensor data. So you can get food ambient, you can get temperatures, light, CO2, whatever, and you can use that to power consumption, and you can use that to build like a digital twin of your building or your facility. And that will help you to, first of all, measure what you're doing, what your energy consumption is, how your people are behaving in the building, and it can also be used to further optimize. So these are things that our customer mentioned for the reason to go for IoT and how it will help in their sustainability story. So what we see with IoT is that typically this is not really driven from the IT department. It is driven from project teams, it is driven from facilities, these are different departments in our customers. And the typical solution they take is that at some point they say, oh yeah, just plug in gateway and network and it doesn't work. Now of course it doesn't work because you're not supposed to plug in DD5 in the network. And this is how it works. So it's already sold to the facilities department, and they need to work on the network. And then it has the drawback that you have for one solution, maybe it's the one gateway, then there's another IoT solution, you put in another gateway, and you have another solution. So this is not really scalable, nor is this sustainable. So what are the drawbacks? First of all, this is cost thing. Putting in separate gateway infrastructures just a lot of money. Also, it's the burden of your operations, so you need to run and maintain multiple infrastructures in parallel, which is an additional cost to your IT and operations. And to go back to the sustainability part, it's not sustainable either. You need to pull additional cables, you need to put additional devices on, you need power, you need switchboard for this, so it's not fitting in the sustainability story either. So would it be nice if we can replace these separate gateway infrastructures with an infrastructure that we have in the building anyway, which could be the AP infrastructure. And this is a real IP. I know that other vendors they have IP radios in their systems as well. So the solution probably will be similar, but it will differ on the details. So benefit of that is first of all, because you have gateway infrastructure already, it will save money because you're already operating it. It will improve your efficiency and roll it out easier because you don't need to make gateways because they are already radios. And in the end, that also will increase the sustainability of your whole solution. In IoT solution, basically the gateways are probably the least important part. Yes, so there's no Wi-Fi, so I'm not sure why I'm talking in a Wi-Fi conference about it. But the main components are the face, and the face, those are sensors, can be tags, and other labels. So these are the source data, or these are really putting your data in this space. And then on the other side, and that's probably where the real value is, that's where you have your applications. And the applications can be things like tracking, it can be facility management, it can be a digital twin of your building. And what's in between basically is just there because you need to connect those things with the applications. Yeah, we as a vendor, we don't create those things. Yeah, we don't create, we have a few of them, but we don't create these applications. And what we've seen is that, especially for an international company like ours, it's very hard because if you are deploying a solution or developing a solution, you develop it worldwide. Especially in Europe, where we have very different countries and different regulations, different requirements. It's pretty hard to create one single solution. So that's why we made the ability to open up the IoT platform in our point and allowed it to basically any IoT thing and integrate with any application. So that's where in the end the value for the customer will come from. So just to show you the cost of the solution, so these are marketing figures. These are also from part of our notion. If you check for the complete infrastructure component of IoT project, what you see is that the majority of that will be the sensors, the devices and things. So it's not the application side, this is just the left side of the diagram. Then the other third of the cost that will be roughly cabling, and it will be gateways. So this is if you deploy a separate solution, separate gateways from the existing infrastructure. Then if you drill it down, so the sensors you will need them regardless if you have the gateway infrastructure in your existing infrastructure or you have a separate infrastructure. But then, if you don't have the gateways, you can cut out the connectivity cost of the gateway hardware. You will still need to have radios in this case. So this is a solution that works 900 megahertz. We don't have 900 megahertz radio in our access point, but we can put it in WLA. So, but having just a radio, it's much cheaper than if you have a full gateway. And you can cut out all the cabling costs because you don't need power gateway. The ADP is already powered. So that's quite a big saving. And to make the market people happy, then you just take the infrastructure costs, take out sensors, they have a really big saving by taking out the separate gateways and taking it into an existing infrastructure. So, what can you build with it? So, in the next points, there is a EV radio. We have a digital radio in there as well. We have USB ports, we'll go into details. But let's first do some examples of solutions that you can build with it. So this is a partner with us based on the WLA and the Wi-Fi signal. We can do indoor locationing. Here's an S tracking where the APs will check an S track. They will receive the WLA signal in the triangulation and plot the device somewhere on the map. And that can dramatically increase is for a hospital solution. You could also put in sensoring, as you can see, temperature, humidity, or other parameters from sensors that are taking the data through the infrastructure and put it in the application. Alarming solutions. This is workplace management, where you can see which locations are used, which are not used. And these are all created by local partners. Many of them are in Germany, but they have pretty specific requirements. This is a solution from Belgium, via with WLA tags that are then taken by the Bluetooth locator. Where you can see it's also some competitor access points and EFF locator as well. Then you go to the cloud platform, you have app, and in the end, this is probably what you care about, and for that you need everything that's on the left. So this is my solution where one hospital, they put sensors on the cell phones, and if staff came in with their badges, they can link the person with the cell phone, and then they can see if they take the hygiene regulations in place, and that's will help them first of all measure and further they can improve see why are they not using it or why are they using it. So many applications, it is an individual solution where there is a vibration sensor on a phone, and what the vibration differs communicates over Bluetooth and then integrate. So there's a wide variety of applications that are available for that. This, for example, our Geneva Innovation Center, where we have deployed sensors and all that, you can basically see for each of the rooms what the temperature and humidity, and it works as your, so you can also go back in time and see play the changes in all the data all the time. There are many solutions that work on IoT. So again, we have things, we have transport, and we have the applications. Maybe we should zoom in a bit on what's happening in the next point. So this is like a rough diagram of an next point and how a complete IoT solution could work, where we have on the left side the different radios, the different radio technologies. On the right side, we have the application side and the AV with its application, with its gateway functions is in there. And let's first look at the radio side of the connectivity. So first of all, because of the next point, we have Wi-Fi radio unit. You can use it to send connected lines, unconnected lines, referrals. So you can do all kinds of applications already based on just Wi-Fi. This application of this is in their phases, but it's still very relevant. Then also, most of our access points have USB ports, and USB ports have the benefit that if there is a radio technology that does not fit in Wi-Fi, Bluetooth, or Zigbee, that's the next point, you can simply put in a radio module over the USB and use that for the IoT connectivity. And there are many versions of it. But the main type of dongle that we have is either a dongle that does the USB serial emulation. So that is like when you need to connect to a switch with the old RJ45 port serial, you put USB dongle to basically saying just that conversion from UV to RFP2 in the specific dongle. The second method which can use is with Ethernet emulation. Again, my MacBook doesn't have an Ethernet port anymore. I have a USB dongle that has USB on one side, Ethernet on the other side. We have also partners that create dongles. If you plug it in the access point, it will show up like an Ethernet port. It will do DHT, and you will have IoT connectivity. So the two different methods of connecting over the USB port. And then we have the built-in IoT radio. And for Aruba, we have the IoT radio, or we do the BLA radio in for ages. And at some point, product management found out that if you have a BLE chip or you have a BLE plus a Zigbee chip, that's approximately the same cost. So from that point on, all the APs they have the IoT radio, which is able to do up to 15 radio on the radio level, and it can do either BLE or it can do Zigbee on that level. So what's the data that we can get out of these radios? For Wi-Fi RTMS, we can get three types of advantages out of it. So it can be tags, it can be all associated clients, associated stations, or we can connect an associated station. The all clients that are around. So if you want to sense how many devices are in a room, you can take the associated client, and you have a rough estimate of how many people are in that specific room. It's not fully accurate, but for many of the applications, where in the end, the output of the application, that's what counts, and not how accurate it is. But it will be, it's cheap because the data is there anyway, and you can just use it. So for the USB to serial, we have a number of vendors that create the dongles. So that one is the one from Notion, runs over 900 megahertz. I think this is shotgun detector, so that's especially for colleagues in the US. You need to detect when someone is firing a gun. Then, for shelf labeling, and Microtech is one of the big things there. That also runs over USB to serial. Then all of them they've chosen the USB to Ethernet, and again on the AP it will just show up as an Ethernet port. It can you can put it in a VLAN, either turn on to a gateway, or you can locally break it out. It will get an IP address, and it will just be addressed as an IP device from that point on. It's pretty flexible in what you can do with it. Then for the built-in, or for an IP radio, we have a built-in one, which is in most of the access points, starting with the Wi-Fi 5 access points. We put in the BLE radio, which was BLE 4 at that time, and the only modern radio they had that. It was 15 radio, which can be switched to BLE 5 or to Zigbee. And then also we have an external dongle, which you could either use for access points that don't have an internal radio. But the actual use case for that is if you want to do Zigbee and BLE on the same access point, you could do that. So you use one of the one internal port, and the other technology you do that on the external USB. So that's the Zigbee. So now we have seen what we have on the IoT radio connectivity side. then also we need to do something with that data. And we've chosen to do that in a kind of open way over an open protocol, which is called WebSocket protocol. And you can use that for northbound and southbound API, with the northbound is putting data from the radios to the backend, and the southbound if you want to send data back. For example, for the shelf labels, you want to change what's on the label, you can use the southbound API for that. And so the preferred way of doing it is that we use a WebSocket protocol tunnel. And WebSocket protocol is a combination of two technologies. So the first technology here is a WebSocket. What WebSocket will do is initiate it from one point, which is typically the access point. It will initiate a connection to an external destination, which can be somewhere in your internal network, but it can also be in the cloud. And we see more and more of these applications running in the cloud, and we need to have a secure way of connecting things back to the cloud. With WebSocket, you set it from the access point to the external application session. The session will stay there, and over the session you can send bidirectional messages. So this also has the benefit that if we want to send something from the server, which is on the internet or in the cloud, we want to send messages back to the access point, you can do that because we have a system set up from the inside to the outside, so this is perfectly aligned with the firewalls that can go out if you cannot go in. And the server would never be able to set up a connection, initiate a connection this way, where you can send messages back to the access point as well. So this is basically a way to set up a bidirectional communication from the access point to the internet or to an application server. And then once we have that session, what we do is inside of that we use protobuf. And protobuf is a more efficient encoding of data. So many of you probably know JSON. So in JSON, you mention IDs attribute as this value, IDs attribute as this value. You can send it over, and then on the other side, you can call this attribute that value. The thing is, if you want to send that data set again, you do exactly the same. So this attribute at that value, this attribute at that value, which is not really efficient. So with protobuf, basically you define in an open way what you're sending, and then you're just sending, I'm sending this type of data point, and these are the values. And that's much more efficient. It's binary encoding of your data. And also this is radio. So if you download this protobuf file, you can create Python libraries from it, or JavaScript libraries, or C++, or whatever you're using for the development. And that's the way then how you can do that. To make it a bit more graphical, if we have a message, we can encode that in protobuf. We put that in the WebSocket communication, where we have a WebSocket tunnel set up from the access point to the application server that runs over HTTP transport, MSL security, so basically HTTPS. Next to there, we decode the SSL, we get HTTP, we get the WebSocket, we get our protobuf messages. And similarly, if we want to set the SMS array around, we'll just take sort of protobuf encoding, and it will go in the section that has been set up outbound, and we can send data back to the access. So how will it look in an actual environment? So for the Aruba instance solution, where basically every AV is autonomous, but customers, they will be a tunnel from every AV. If you have a controller environment, they will you have a lot of details, yeah, you need to make sure if you have 10,000 APs, that all servers can handle 10,000 connections at the same time. So there are also solutions where you can put an IoT connector in between to aggregate the data and send it over to the backend. The WebSocket interface, definition of that is open and freely available for everyone to download. Same applies for the those specifications. So basically, that means that every vendor or every customer or every partner who wants to get started with this, they can just download the specifications and get started. Once we have the data on this side and the connectivity on this side, yeah, we need to link those together. So what data we want to have from there to there and vice versa. And that's what we do with transport services. So basically, that's a filter that we put on top of it, so we can define which type of messages go where. So for the Wi-Fi data, you can associate it and the Wi-Fi tags. For BLE, we can either have BLE telemetry. So with the BLE telemetry, we just get the MAC address and the signal strength of the thing. Obviously, we can only get the count of the devices. If you want to know how many BLE devices are in the operating access point, you can get the data. For counting purposes, the telemetry is good enough. If you need to have beacons that also have data, we can use the BLE data where we send in addition the payload, so the complete BLE frame. We just forward it to the application, and then we don't need to know what it is. The application will know what it is. We can just work forward that data to the application. For some BLE Bluetooth devices, you will need to have kind of serial connections, so you can also connect from the access point to a BLE device, completely set it up with encryption and authentication to the device. And once you have done that, you get a kind of serial communication which runs from the access point to the device, then over the API gateway of the API connection. You can control that device, which is somewhere in the environment. So the serial data can also be bidirectional, so you can send data to the devices, you can read data from the devices. We try to make it as open as possible. Similar technologies for ZigBee. So with ZigBee it's slightly more complex. Because for example, if you have a Philips Hue which is using ZigBee under the hood, they imagine that you buy a Philips Hue and you buy a Philips Hue bridge, and then eventually works together. But there are specifications that are under the hood, which are using source designation, profile, IP, those things for enterprise ZigBee applications. You probably get those from the vendor of the ZigBee devices. So that's how you then can implement it with ZigBee and ZigBee applications. Like robots and so on can be done like that. And one not really recent improvement is that in the past our engineering team, they created like a vendor for each of the applications that we have tested. An integrator, so you have drop downs, so you have a blind beacon that you could just take by it. It was having a macro data, you can take that on drop down. We now also have the option that you can get that generic beacon fields, and this basically allows you to allow any BLE device on your BLE. You can allow it on the network and transport the data to an application. And this also allows you to create your own applications that our engineering has not thought about. other topic that comes up every now and then is because with Wi-Fi, we are well aware of the security, what to do, what not to do. With IoT, because we're using other radio technologies, that's less clear. So if we take the diagram again, for security things to evaluate are the IoT device itself. If it's addressable, you probably can attack it. But then that is not something we really can do, but it's something a vendor should take care of. Then also you have the radio communication. And with WLA you have optional encryption. With Zigbee there's mandatory encryption, it's just that there is in specification a default key, and many Zigbee applications they use the default Zigbee key. And if you have that Zigbee key, you can just decrypt the communication, you can intercept, you can inject messages. So this is at least something you need to be aware of. Also, these dongles, they can work also unencrypted, which potentially allows someone to spoof cellular data. Is that a big issue? It depends. It may not, but we need to be aware of it and evaluate the risks. For the USB port, we can put legislation on the access point that we only allow specific devices to access the AV, so you can prevent anyone from putting in other devices by charging their iPhone. For the Ethernet, so devices that are using Ethernet emulation, we can put access lists or roles basically on that's allowed to the infrastructure. In the access point, we have transport, so where we configure what data is going where. So you probably don't want to have all your BLE access data going to all your third-party vendors. So you can filter that, you probably should filter that. And on the kernel, especially when you go to the cloud, make sure that you have SSL encryption and they do proper certificate checking as well. So the traffic cannot be intercepted and it's secure while on transit to the third-party application. And as well, the third-party application itself, it's also typically cloud application accessible. But it's something that the cloud vendor needs to work on, or the application vendor needs to work on, that is secure as well. Then there is something else with the connecting the IP networking and the IoT or OT networking. We see there are many also non-IP IoT solutions, which typically at some point have a gateway. Yeah, so the gateway, once that comes on the network, we can do network authentication on those devices. We can put access roles on that so they are firewalled and it only allows specific applications. So if there is an IoT service, you can make sure that this device cannot go to the rest of your environment, can only go to the IoT solutions. So these are things that you should take care of. Also, there are a few vendors that focus on OT or IoT security. So if you run OT networks at scale, it may be good to get one of those vendors, and you can probably link that together with the network access control in your IT network. But what we are seeing is that where these networks in the past were completely isolated and separate networks, that's not longer sustainable. So they are merging together, or at least they are linked together at some point. Then Mark asked me one thing. He said, probably you don't have a story about it, but LoRaWAN came up. So the thing is, LoRaWAN, you can use it for IoT. but the properties are quite different than we have with Wi-Fi. So with Wi-Fi, you typically speak about a radio range of 10 to 20, maybe 30, 40, 50 meters. With LoRaWAN, it will be very large distances. So in optimal conditions, it's can be 10 kilometers. It also means that you probably need one or for redundancy 2 gateways for your typical facility. So that doesn't make it a logical choice also to integrate it in the wider infrastructure. So I think we're working on a USB dongle that can do LoRaWAN, but yeah, especially if you have applications like these where you need 1 or 2 or 3 gateways, then maybe put those separately because it doesn't really make sense to integrate it with the Wi-Fi deployment. And another thing to consider is that for LoRaWAN, all the devices need to have a LoRaWAN radio. Another thing that comes up, especially with the marketing of big carriers, 5G, also perfect for IoT solutions. Again, there you need to have a device with a 5G radio and typically SIM card or eSIM in it. Not all devices do have that. Also for 5G, it's more like a service provider way. They want to sell you a subscription, they want to sell you calling minutes and bytes sent over. So it's quite different than Wi-Fi where you usually free spectrum and you put in infrastructure and based on fair use you let the information freely flow. So it's quite different. Also, for that use case, the 5G radios typically have a much larger distance and range than the Wi-Fi radios. So it may or may not be logical to combine those together. Then I already mentioned with IoT is incredibly important that you know we are talking to. So in general, IoT projects are not run by the networking or the IT department. They're run by HR that want to increase employee satisfaction or deliver a healthy work environment, or it's a facility that need to get data from the building and improve or optimize the energy consumption. And also in general, they are people that make the buying decision, and then IT or networking needs to fit that on the networking. So you probably need to make sure that you are early in the process with them and let them understand that they can use the Wi-Fi infrastructure that's already there to use it as an IoT infrastructure that has benefits not only for the cost, but also for the sustainability and the operational efficiency. Okay, to summarize, we have devices that generate data, that display data, and we have applications that provide insights that allow you to do smarter business and get better outcomes. You need something to transport the data between those two. There can be separate gateways, which are pretty costly, which are not really efficient, but after all, they're definitely not sustainable. And if you have the infrastructure there already, you probably can use your Wi-Fi infrastructure to perform that transport. If you have it open, it also allows that you can do your own applications, your own solutions that we as Aruba have never thought of, or that maybe for us as Aruba are not as relevant as they are for you as a customer or as a partner. And for the political side, be sure if you know who are working on IoT things and get involved early in the process. That's it. Thanks a lot. Yeah, let me just know if there are any questions. Yeah.
You show that the Zigbee radio, low energy, it's all in the access point, and you make a web connection to a backend server.
Yeah.
Is there a way to tunnel that back to say control, or do you need to connect to your access?
So if you have a controller solution that will, the controller will be the application point, so it will go over the controller. Yeah, I had to take out some data also because it's on a presentation. Yeah.
Does it offer, or is it just fire and forget, and if there's no WebSocket connection because something's down, it just forgets things?
So if there is no, you have no WebSocket connection, then probably the application will at some point notice, oh, I'm not getting data in, so it cannot work at that point.
Yeah, okay, but it does throw away everything it gets from the IoT sensor.
It does, yeah, at that point, yeah. There might be some buffering, but in the longer term, yeah, it will be thrown away because APs are not there to store data. Yeah.
Thank you.
Well.